Geotechnical Engineering, Part A, Soil Mechanics, Chapter 7, Permeability. Equivalent hydraulic conductivity in stratified soil. This time we want to calculate hydraulic conductivity in vertical flow direction. So our seepage or our flow direction through the soil is the vertical this condition. So this time we want to determine the equivalent hydraulic conductivity stratified soil, which consists of different layers of soil, a vertical flow direction. So we are looking KV equivalent. We just consider a cross-sectional area of A with all the samples. So our area is the same. We can simply know this time our Q is the same through all the layers is equal to Q. The same discharge passes through all the layers. So Q1 is equal to Q2 is equal to Qn, and that's equal to total discharge. But this time we simply know head loss delta H total is a combination of delta H1 plus delta H2 plus delta Hn, and that means total head of water is just a combination of, so at the first layer, as the water travels from the first layer of soil to the second one, delta H drops by delta H1, passing through the second to the third, it's delta H2, and it's just go on reducing with the same pattern, delta H3, delta Hn, and then combine all of them, it just gives you the total head loss between the water. And head loss, in the drop of head loss, it means how much water get tired, then travels from the first layer to the second layer. So that's the delta H1. The tiredness, that's a measure of the tiredness of water when travels through different layers of soil. That's delta H1, H2, all of them together. If you add them up together, it just gives you the total head loss between all layers. So if you want to say the main assumption for vertical flow direction, it just gives us Q remains the same in all layers, like what you can see here. The same amount of discharge passes through all the layers, and total head loss is a combination of all the head loss within the layers. So those are the two main assumptions in vertical flow direction in terms of calculation of equivalent hydraulic conductivity, or K vertical equivalence. So if Q is the same, we simply know discharge is equal to velocity times area, and velocity itself is K times I, hydraulic conductivity times the hydraulic gradient of soil, and that's K1 I1 A times A1 is equal to K2 I2 A2. If we just cancel out K1 I1 A1 is equal to K2 I2 A2. If the cross-sectional area is the same in our sample within the layers, we can easily cancel these two out. Just gives us a K1 I1 is equal to K2 I2 is equal to Kn In. Ki is also velocity, so it just says velocity remains the same in all layers. So if velocity remains the same in all layers and head of water is consisting of all of them, H1 plus H2 Hn, that's delta Ht. We can also call it delta H1, delta H2. That's just the measure of the head loss of water. I is equal to hydraulic gradient of soil. I is equal to delta H over delta L. Head loss over the length of travel. So if we just consider the length of travel for whole layer like H, capital H, and delta H by lowercase h. So lowercase h over capital H is representation of our hydraulic gradient soil. So if I is equal to h over capital H, if we just rearrange the equation and write it based off h lowercase, it just gives us h lowercase is equal to h1 I1 plus h2 I2 so on plus hn in. And if v is equal to v1, we can write it like total velocity is equal to v1, that's k vertical equivalent over h capital, which is I, is equal to v. So if that's the case, we can rearrange this equation, and at the same time we do I is equal to h over h. If we rearrange this equation based off h and simply place this h in denominator of the top equation, so in that case we can have a k vertical is equal to v1 times h. Instead of h lowercase, we just replacing the h1 I1 plus h2 I2 each layers. And at the same time, we do know v velocity is equal to k times I. So if we want to calculate I is v over k for each layer. So for example, I1 is equal to v k1, v over k is equal to k, and that's h1 times v1 k1. You replace that for all layers. We do know from previous slides that velocity remains the same, so is equal to 2 is equal to v n. So if we just factor out velocity in denominator, and because v is equal to v, can cancel these two out with each other. So in that sense, k vertical hydraulic vertical equivalent hydraulic conductivity in soil is equal to total height of all layers, height of the overall layers, all layers over h1, height of the first layer to conductivity of first layer, plus h2 in denominator over the conductivity of second layer, and plus h3 over the, if you have it like kn and hn, you can just go on and calculate vertical hydraulic conductivity. And thank you. We'll solve a numerics problem to have a more deeper understanding of the issue. Thank you.